Not all companies afford training 100 billion parameter neural networks for weeks in a row on super powerful machines. Actually, most of the companies don't. While the giants steer the landscape of deep learning, the rest of us can benefit from their work and use it to our advantage by building on their foundations. Hi, I'm Ioana, a senior data scientist, and these are some concepts you don't want to miss out in 2024 if you are a data scientist yourself or if you are just an enthusiast in the advancements in the field of deep learning. Multimodal neural networks are one of the most promising trends in deep learning currently, as they are designed to predict based on a more holistic understanding of the world. Researchers are on the quest to mimic the behavior of human brain when taking decisions, and as the brain considers information coming from multiple modalities like vision, taste, or senses, multimodal neural networks can simultaneously process data coming from different modalities, visual and audio or visual and text. Previously, neural networks were specialized in understanding a single modality, like convolutional neural networks were adapted for images. Transfer learning is a technique used to leverage the assets of billion-dollar companies which have the financial and intellectual resources to train huge models on big amounts of data. You can take a classifier which was previously trained on animal pictures and use the feature extractor of that classifier to extract features from a new dataset, like medical images dataset. By only adapting the final layers of the network, also called the top layers of the network, you obtain a brand new classifier which can now be used on classifying medical images. Fine-tuning is just another flavor of transfer learning which involves more effort on your side. Instead of simply taking the feature extractor and using it as it is, you now allow some layers of that feature extractor to be adapted to your new dataset. Therefore, besides changing the parameters in the top layers of the network, you are now also unfreezing some layers in the feature extractor and updating the values of those parameters as well, such that the newly trained model performs best on your dataset. Keep in mind that the network architecture or the backbone is going to be unchanged. It will have the same number of parameters as the pre-trained network, but only the values of those unfrozen layers and the top layers are going to be changed. Knowledge distillation, on the other hand, will tweak the architecture of the network as well, not just the values of the parameters. Knowledge distillation works with the concept of a teacher network and a student network. The teacher network is larger, has more parameters, and it is more difficult to deploy, requiring more resources. The student network, on the other hand, is a lightweight network, to which knowledge is being transferred without a significant loss in performance. This concept is used in edge computing, because on devices such as mobile phones, tablets, medical devices, or industrial robots, the amount of memory is low and therefore lightweight architectures with high performance are required. With the progress and explosion of natural language processing, knowledge distillation has become a very powerful subject, as it allows that knowledge from billion or 100 billion parameters network to be transferred to very lightweight networks that can be used on any device. RAG stands for Retrieval Augmented Generation. Using an analogy, imagine you have a company that sells some toothpaste. You hire a new salesperson and this person has some previous experience in sales, actually it has activated in the field of cosmetics. So it has also the field experience. Nevertheless, without having in-depth knowledge of the products that you are selling, probably he won't really know how to emphasize the benefits of that product to the customers. Most probably, you would like to give that person some catalogs that would emphasize the features of this new product that he's selling, the prices, the offers, and so on. That's exactly the concept around which RAG revolves. It provides a pre-trained LLM or large language model with a context that is specific to your scenario through some documentation, such that the LLM can afterwards answer questions more precisely. RAG made possible the transition of chatbots towards conversational agents. Zero-shot learning is a deep learning scenario in which a neural network can predict classes it has never seen during training. So you may be wondering, if you're training a classifier with fish pictures and persons pictures, is that classifier going to be able to correctly predict a mermaid when I give it a picture of a mermaid? And the answer is yes. Because first, these models are trained on really huge amount of data. And secondly, because besides providing images or visual representations of the data, you are also providing semantic representation of the data. Therefore, the better the model can capture patterns, structures, and relationships in a data, the richer the feature space it will learn. One amazing example in this sense is CLIP. CLIP stands for Contrastive Language Image Pre-training. It was developed by OpenAI jointly with UC Berkeley, and it was trained on around 400 million image-text pairs. It can classify images into categories it has never seen before. And CLIP was actually a breakthrough because previously state-of-the-art computer vision classifiers had to be further trained each time a new category or a new class would be of interest. And now all of a sudden, here comes this model which has amazing generalization capabilities. Okay, but this is not the classical classifier. Well, no. It is based on the concept of contrastive learning. It focuses on learning discriminative features that bring objects together as well as setting objects apart. And this has to do technically with how the architecture of the network as well as the loss function are built, because contrastive loss requires pairs of data which can be positive pairs if two images are considered from the same class, and negative pairs of data when the two images come from different classes. Notice that the class of each object is not mentioned anywhere. Only the label defining the pair constitutes an interest. This is what makes contrastive learning super popular, as it bypasses the need to label data, which is an expensive and time-consuming process. Contrastive learning is part of the self-supervised learning paradigm. I hope you will also try some of these concepts. If you found this video interesting and you would like to learn more about data science topics, then don't forget to subscribe to the channel. See you next time!